Alrighty, so to finish up here, our third video in this notes guide is going to cover really just two specific problems. One I wanted you to try on your own, a cross-section problem, and then an AP free response problem that was calculator active. So let's take a look first off at example 11. I think it's so important that we basically just do simple stuff first, right? Understand what this thing looks like when we graph it, right? So there's 2 right there. And kind of down 2 over 1 that thing, right? Here we go. Y equals negative 2x plus 2. Y equals 0 and x equals 0 are telling me, okay, this is bound in the first quadrant. Right, so I'm dealing with this region right here. Now, they then tell us that we are dealing with perpendicular cross-sections to the y-axis, and these are semicircles. So think of it this way. The diameter of these semicircles lies perpendicular to the y-axis. So we're thinking of it like this, right? Which means first and foremost we need to change this in terms of y. So x is going to equal y minus 2 over negative 2. Here's the other thing we have to remember. That represents the diameter. If we're using either cross sections or squares or even semicircles especially, we need to understand what we're looking at in terms of finding the area. So the area of a semicircle is 1/2 pi r squared. So this is the diameter function. The radius function, we've got to cut this in half. So this is really negative 1/4 y plus 1/2. So we'll get back to that here in a second. Now, how do we set this thing up? Well, we also have to remember that we're using bounds that are along the y-axis. So our setup, right, would be 0 to 2 pi r squared over 2, so we can actually put the pi over 2 outside, right? And then the r squared, which is right here, negative 1/4 y plus 1/2. Looks as so. Now we will have to do, we don't have to, but we probably would do some type of a u substitution here. So we would say like u equals negative 1/4 y plus 1/2. You don't have to do that. You can expand it. This is probably a little quicker. So we get u equals negative 1/4 dy. We're off by a negative 1/4. So what's that mean for us, right? Well, we're doing pi over 2, times negative 4 integral of u squared, right? So I'm going to let you continue to play around with this. Really, we get ourselves to a point where we're going to integrate here and do our thing. We can clean this up for sure. So this is basically negative 2 pi. And then, of course, u to the third over 3. And we want to probably go back in there unless you're doing the switch of bounds like we've talked about. So just to kind of keep it simple here, negative 2 pi times negative 1/4 y plus 1/2. All that's cubed. And then why don't we go ahead and also take the 3 out. Right, so it's really negative 2 pi over 3. And then let's evaluate that thing from 0 to 2. And when we finish everything up in here, negative 2 pi over 3 is going to be multiplied by, well, it winds up being, you plug in 2 here, and you get 0. Plug in 0, and you get 1/8. So we should get a final answer here of pi over 12. Okay, so this AP free response question, notice it's calculator active, so you really don't want to do too much here by hand. The first 2 parts are really just asking you for area and volume. Third part is just asking you for the setup and not an answer. So kind of keep that in mind. And as we usually say, right, with these videos, if you want to try this on your own and pause the video and come back and take a look, that's great. The one thing that I'll point out here is we are going to need to find these points of intersection. And I think what might be helpful here is if we find them, why not just go ahead and denote them, right? We'll say let A equal, and the first one winds up being negative 1.264. I did these actually on decimals. I didn't have my graphing calculator handy, so you should take the decimals out. Decimals went ahead and rounded these guys off. And we're going to let B equal 1.278, right? So when we get to part A, here's what that looks like. The area would be the top curve minus the bottom curve, right? So we can actually say A to B, integral of A to B. And then the great thing here is they've defined f and g for us, so we don't have to write the entire function out. We could just simply write f of x minus g of x. Show them we know what we're doing. And then we can, of course, put this in our calculator and let's see what we get. Looks like we come up with 4.547. Okay. Part B. They ask us to find the volume of a solid rotated around the line y equals 2, which is up here, right? Which means there's vacant space in between our shaded region and the line we need to revolve it around. So this is a washer problem. Not only that, but we have to understand that this bottom curve really will serve as the outer radius because that curve is farther away from the axis of revolution. And then f is going to serve as my lowercase r, my inner radius. So what does this setup look like, right? Again, it's a setup and answer, basically. So, of course, we have pi on the outside. We are going to go from A to B. And now, remember, it's the outer radius squared, but it also incorporates the line of revolution here, right? So I like to do 2 minus the outer radius. So in this case, it would be 2 minus g of x. Square that. 2 minus the inner radius, square that. We've talked about this before. If you like, you can do g of x minus 2 and f of x minus 2. It's commutative in this case because we're squaring it and you'd be okay. Let's see what we get for an answer there. And including the pi here in my answer, I get a total volume of 66.849. Okay, and finally, part C. Now, the good thing about part C is it tells us the scenario. Region R is base of a solid, semicircular cross-sections perpendicular to the x-axis. And it says set up but do not evaluate the integral. So, in this case, we did talk about that little bit of a shortcut there, that pi over 8 you can do. We can go from A to B, right? And then remember that we are dealing with now a square if we do the pi over 8 shortcut. And so really the side of the square is just the difference in the curves. So we're looking at f of x minus g of x quantity squared. And that's it. We don't have to do anything with that. We can leave that as our answer. Okay, I hope these videos have been helpful. As always, doesn't mean it's answered the questions for everybody, so be happy to answer these when we meet back again in class.